Every time you ask an AI for a recipe or a poem or, the answer to some complicated question, something is happening behind the scenes. It feels so instant, so digital, almost weightless, right? But there is a very real, very physical cost to all that magic, an invisible but absolutely massive demand for energy. So today, we're going to pull back that curtain and look at the hidden power consumption of this AI revolution.
So let's just start with a simple question that really gets to the heart of all of this. We interact with AI constantly now, but have you ever just stopped and thought about what it actually takes to get that single generated response? Well, it is way, way more than you might imagine.
And this is where that energy cost just explodes. See, a simple web search, well, it just finds information that already exists somewhere. But an AI query, it has to create a new answer from scratch. And that creative process, what they call inference, is what makes AI so powerful, but it's also what makes it so incredibly power-hungry. Now multiply that by billions and billions of queries, and you start to see the sheer scale of this growing global paradox.
Yeah, we're basically living in an AI power paradox. The convenience is amazing, we all love it, but it's being built on a foundation of rapidly growing energy demand that our world is really struggling to keep up with.
Okay, take a look at this number. 536 terawatt hours. That's the projected electricity consumption for global data centers in 2025. To put that in perspective, that's about 2% of all the electricity used on the entire planet. Now, I know what you're thinking. 2% might not sound like a full-blown crisis, but that number, that isn't the real story. The real story is how fast it's growing.
And here is the comparison that truly matters. Data center power demand is set to grow by around 15% every single year. That's more than 4 times faster than all other electricity use combined. This makes AI and the data centers that house them the single biggest driver of new electricity demand on the planet. Period.
So where is all this energy actually going? Let's take a look inside these massive, humming buildings that power our entire digital world.
To really get a handle on that power draw, it actually helps to think of electricity like plumbing. Seriously. Volts are like the water pressure in the pipe. Amps, that's the flow rate, how much water is actually moving through. And watts, well, that's the total power. It's the pressure multiplied by the flow. Watts are what you get billed for, and it's the key metric for all this energy consumption.
So where do all those watts actually go? Well, inside a data center, the breakdown is surprisingly simple. About 40% goes to the actual computing, the servers and chips doing all the work. But another 40% goes just to cooling everything down. These high-powered systems generate an incredible amount of waste heat. So yeah, nearly all the power is for just 2 things, running the computers and stopping them from literally melting.
Okay, now let's zoom out from the single data center and look at the bigger picture. This immense hunger for power is putting just an unprecedented strain on our entire energy infrastructure, and it's creating what we can call the Great Grid Bottleneck.
And right here, this is the core conflict. You can build a brand new, state-of-the-art data center in about 2 years. But building the new transmission lines and power plants you need to actually plug it into the grid, that can take up to a decade. Technology is moving at light speed, while our foundational infrastructure is just moving at a crawl. And this isn't just some theoretical problem, In places like Northern Virginia, which is the global hub for data centers, this bottleneck is very real. You have companies building these massive facilities, and then they have to wait, sometimes up to 7 years, just to get them connected to the power they desperately need.
The price tag for keeping up is, well, it's staggering. The total capital investment needed for data centers is projected to hit nearly $7 trillion by 2030. Just to give you a sense of scale, that's more than the annual GDP of every single country on Earth except for the US and China. It is the immense cost of building the physical foundation for our digital future.
And make no mistake about what's driving this cost. Over 70% of that $7 trillion will be spent specifically to meet the demands of AI. This isn't just about more emails or websites. This is the AI revolution literally reshaping our physical world.
But this kind of pressure, it creates innovation. And in response to this energy crunch, the tech industry has entered a full-blown efficiency arms race.
So the battle is being fought on 3 main fronts. First, chipmakers are redesigning processors from the ground up, focusing not just on raw power, but on performance per watt. Second, companies are moving to advanced liquid cooling. And third, they're getting a lot smarter about how they buy power, using strategies like power purchase agreements, or PPAs, which are basically long-term deals to secure electricity directly from renewable energy producers.
The move away from air cooling is a perfect example of this shift. High-density AI servers run so hot that just blowing air over them isn't enough anymore. It just doesn't work. And as a result, the market for liquid cooling is absolutely exploding, from submerging servers in special fluids to pumping coolant directly to the chips themselves. I mean, a five-fold expansion, that tells you this has become an operational necessity.
And this shift, it changes the entire calculus for the tech industry. For decades, the mantra for building anything was location, location, location. But in the age of AI, that's being replaced by something new: power, power, power.
Now, how does all this global infrastructure drama affect you and, the device that's probably in your pocket right now? This great power shift is fundamentally changing what we look for in our gadgets.
And this power shift is really changing our priorities. A recent global survey found that a massive 85% of consumers now consider sustainability an important factor when buying a device. It's no longer just some niche concern. It's a mainstream demand that is forcing companies to completely rethink how they market to us.
And companies are paying very close attention, and their marketing is changing completely. I mean, the old playbook, it was all about raw performance and flashy design. The new paradigm, it's all about longevity and efficiency, promoting recycled materials, extended software support, and a longer overall lifespan for our devices.
And you can see this happening right now. Apple's marketing is built around its plan to be carbon neutral by 2030. Samsung ads now heavily feature long-lasting battery life. And then you have companies like Fairphone that are built entirely around longevity, guaranteeing software support for up to 8 years, which is a direct challenge to that whole idea of planned obsolescence.
So we end with this thought. For years, smart technology meant more power, more speed, more features, but as the hidden energy cost of all that power becomes impossible to ignore, our very definition of smart might be changing. This great power shift is forcing all of us to ask, what do we truly value in the technology that shapes our lives?